Okay, this is 3.7 Transformations of Polynomial Functions by Fabian and Luis. Some background information before we get into the video. Some vocabulary here. A polynomial function is an even function if it is symmetric about the y-axis, and an odd function if it is symmetric about the origin. I'm going to reread it. A polynomial function is an even function if it is symmetric about the y-axis, and an odd function if it is symmetric about the origin. Okay, next slide. Now here we have the types of functions. On the left-hand side, we have an even function. You can see it looks like a parabola. On the middle function, we have an odd function. And on the right-hand side, we have a function that is neither odd or even. Here, we have some practice problems for you guys to try and find out what type of function these functions are. So go and try to answer 1 through 3. Try to find out if they are odd, even, or neither. And you can pause the video, try to find out. Okay, now moving on to the next slide to see if you guys got the answers correct. Okay, hopefully for the first question, you guys got odd. It's an odd it's an odd function due to the odd exponent. You can also look at the graph. That's what an odd function looks like. For number 2, it's an even function due to the even exponent. 2, it's an even number. And it's a parabola. It looks like a parabola. And number 3, again, an even function due to the even exponent. Again, looks like a parabola. There we go. Okay, now examples of transformations. Okay, some problems for you guys. Describe transportation and graph a function f of x equals x squared. Okay, on the left hand side we have g of x equals 3x to the power of 2. If we look at the graph, you can see the 3 in front of the x squared made the graph wider. Now, onto our second problem. H of x is equal to x plus 3 to the power of 2. If you look at the graph, the 3 in the parentheses made the graph shift to the left. That's how it works. And then on the right hand side, look at the graph, look at the equation. J of x is equal to x squared minus 3. The negative 3 made the graph shift down 3. The red is the original function, and after we added the negative 3 to the equation, we can see a shift down 3 units on the y-axis. And then for the middle function, it shifted 3 units to the left because of the positive 3. And here on the first one, it just made it wider because of the x squared. Yeah. So let me try to explain this again. For the middle function, since the 3 is inside the parentheses, it's gonna shift it to the left. If it was a minus 3, it would have shifted to the right. Now, on the third function, j of x equals x squared minus 3, since there is no parentheses, we use that 3 or that number outside the parentheses to move the graph up and down. And that is it. Thank you very much for watching.